today we are going to look into the topic resolution in proposition logic. We all know that proposition logic is a building block of logic, and it is actually a declarative statement which is either true or false, but not both. There can be many kinds of connectives such as and, or, implies, by, conditional. All these connectives can be used to form complex propositions. Now we'll see how resolution is going to work within propositional logic. We all know resolution is a proof technique, and we have a set of axioms S and proposition alpha that has to be proved. So the steps that are involved are given here. The first step is converting all the propositions in S to clause form. That is the axioms that's were given to us to clause form. Clause form in the sense, in the case of propositional logic, it means that you have to remove all the connectives such as biconditional, implies, etc. and the final statement should be in the form of and, or, and not. We should only have connectives and, or, and not. So first step is converting all proposition in that particular set of axioms to clause form. Second step is, since we are going to prove alpha is true, we should negate alpha and convert it as well to clause form if it contains any biconditional or implies connectives, and then add to the set of axioms. Now we'll repeat the next two steps until we get a contradiction or we are stuck up somewhere because of some reason. So first step is we'll find out two clauses in the form that alpha, or which are in the form alpha or p and y or negation p. If we find out these two clauses, then we can resolve them and the result will be alpha or y, and that resolvent can be added to S. We keep on doing this, continue this these two steps until we reach a contradiction. So we'll see an example now. We have been given axioms P, four axioms P and Q implies R, S or T implies Q and T. Here we are going to prove that R is true. Now first you have to convert it into clause form. So P, we need not convert it into clause form, it will be directly P. But P and Q implies R has a implication here. So we are going to convert P and Q implies R to clause form. So we can use the formula P implies Q is equal to negation P or Q. So we can use that formula here and convert it into not P or not Q or R. So the final clause form for this particular proposition is not P or not Q or R. Similarly, for S or T implies Q, we'll get a conjunction of two statements, negation S or Q, negation T or Q. Since their conjunction is true, we can assume that they are individually true. That is, negation S or Q is also true, negation T or Q is true, and these two statements can be used. Now T, we need not have to convert it into clause form. So and at the end we have five statements here: P, negation P or negation Q or R, negation S or Q, negation S or Q, negation T or Q, and T. Now next we'll move on to how we are going to perform resolution on this. Since we are going to prove that R is true, we have taken negation R as true. Now we find out some statement in our set of axioms which has the opposite, that is negation of this particular statement. So we only have one statement like such that is negation P or negation Q or when we resolve these two, we get negation P or negation Q. Now again we go search in the set of axioms which is the statement which has a negative form of this, negation form of this. So we get negation P or Q, and negation P or negation Q, we have a statement called as P. So we again resolve them, we get a answer as negation Q. Now again we look at which of the statements have a negation form of negation Q. Again we have negation T or Q, so we get negation T. Now we have a statement called as T. When we resolve these two, we reach a contradiction. Hence, we can say that since we assumed negation R is true, we can say that negation R is true, we can say that R is true. Okay, thank you everyone.